Hello Math 7 students, this is Utah Middle School Math Project 4.2c Equations of Proportional Relationships. In order to be successful today in 4.2c Equations, we have to have a really solid understanding of constant of proportionality, which is what our previous lessons covered. So we are going to start with this quick poll. Looking at this table, I need you to find the constant of proportionality. Review that in your notes if you need to. Find the constant of proportionality for this table. Pause the recording until it's done. In our previous notes, we saw that the constant of proportionality is the number we multiply by as we go forwards across the table. So when I'm looking at this table, although I can see that there is a really nice pattern, like I know that this 2 can be multiplied by a 3 to become a 6. And 9 multiplied by 3 is 27, and I can see a beautiful pattern, a great relationship. However, since the constant of proportionality is the number that we multiply by as we go forwards across the table, we need to be looking at how a 3 changes to a 1 or a 6 changes to a 2 instead of the reverse order. That's the first most common mistake that I saw. You guys recognize that we can multiply by 3, but that's going backwards. The good news is if you notice that we can multiply by 3 going backwards, you can also very easily change that. When I go forwards, instead of multiplying by 3, maybe you can see instead that we are dividing by 3. That's great. However, the definition of the constant of proportionality is the number that we multiply by. And if you see that division relationship, all you have to do is remember that when we divide by a number, it's the same as multiplying by the reciprocal. So as I go forward across this table, I'm multiplying by 1/3. 3 times 1/3 is 1. 27 times 1/3 is 9, and so on. So since the constant of proportionality is the number that we multiply by, I now know that I'm multiplying by 1/3. What I should have typed into the calculator is the number 1/3. The constant of proportionality, the COP, is 1/3. Now that we've got that in our warm-up notes, let's make sure we learn from those mistakes as we move on to equations of proportional relationships. Okay, Utah Middle School Math Project 4.2c. Our focus here is on equations of proportional relationships. So we have the situation, Peter is renting wave runners for a company party, and each wave runner holds 3 people. So with that, we can fill in this table. If we rent 0 wave runners, that's going to help out 0 people. But if we rent 1 wave runner, how many people will be able to be on that 1 wave runner? Thank you. This one's a tough one, right? Because the answer is staring us right here in the face. Each wave runner holds 3 people, so one wave runner will hold 3 people. And 2 wave runners is going to hold 6 people. You know exactly what we're doing here, right? Jumping ahead. How are we going forward across the table? How are you doing this so quickly in your head? What's happening, Cambria? Yes, we're multiplying the number of wave runners by 3, so I'm moving forward across this table by multiplying by 3. Again, remember, I'm color coding. Orange is the color that I use for the constant of proportionality, so we're going to multiply by 3 as we go forwards across the table. But in this one, I'm not going forwards across the table. I'm going backwards across the table. So since I'm going backwards across the table, what am I going to do instead of multiplying by 3? This is where I should see lots of hands, because this is an easy one. Get those easy hand raises out of the way. Alexis. We could divide by 3, absolutely. That's my favorite way of doing it. There's another thing we could do. What else could we do? Alternatively, we could trace. Yeah, we can multiply by its reciprocal 1/3. Either way is fine. You do what works best for you. So 9 divided by 3, or 9 multiplied by 1/3, is going to be 3 wave runners. And this is why it's really important to find patterns as we go across the table instead of just as we go down, finding equivalent ratios, because now I skipped 4, 5, and 6, and I'm jumping to 8, which is really not a big deal as long as we know this pattern. We know that when we go forwards across this table, we're multiplying by 3. Yes, Luke? Oh, that's okay. 8 times 1/3 is, or excuse me, 8 times 3 is 24. So what am I going to do now? Randomly now we have this W. What does the W even mean? Let's talk about that for just a quick second. Okay, talk with your groups first, because I'm getting no engagement from you. So talk with your groups first. What in the world does the W mean? Why is it even there? Okay, and now back to me. What do you think that W even means? Why is it there? Gideon. Yeah. Yes. So it does represent the number of wave runners. It's in the W, or it's in the wave runners column. So that's exactly what that means. Why did we switch to a W? All the others were numbers. So why am I all of a sudden changing to a letter here? Why do you think we would do that? Zuri? Yeah, exactly. We don't want to have to list every single possible number of wave runners that we could rent. So the W represents any number of wave runners that we could represent. And if we can find out what to do with this W, then we're going to know what to do no matter how many wave runners we rent. To help us, I also have this table here. So we also have this table over here where we can see all of the same numbers of wave runners here on the left-hand side. We've got this extra column here. And then we have the result, how many people. Let's fill in that part as well. I want to focus on this. We have one wave runner, so we are taking that one wave runner and multiplying it by 3, because that's our constant of proportionality. That's how we're going across the table, is by multiplying by 3. And 1 times 3 gives us the result of 3. So let's continue on. Now, all I've done here is I've just created this extra column. So instead of me trying to squeeze in this times 3 as I'm going across the table, I now have a column that's going to show that. So 2 wave runners, but to go forwards across the table, I'm multiplying by 3. So those 2 wave runners multiplied by 3 is equal to 6, which goes in that other column. Take a second and fill in the rest of that table. You can discuss with your groups if you would like to. I'm also going to be filling it in on the recording, just quietly. You can always check your answers once you are done filling it in. Make sure that they agree with what I have. Let's see, 3 wave runners multiplied by 3 is equal to 9. All right, how does it look for you guys? Look the same? All right, what am I going to do down here then? What am I going to write right here? Carter. Exactly, W times 3, which you also recognize there's another easier way of writing that, but for right now, let's just keep it W times 3, because it doesn't matter what's over here. We take what's over here, we multiply by 3 to go forwards across the table, and what am I going to get when I take that W and I multiply it by 3? You can keep it W times 3 if you would like to. That is fine. But also, you guys are sophisticated 7th grade mathematicians, so you know that W times 3 is written as 3W if we're lazy, right? And that's maybe a little bit better. And guess what? You've written an equation. Okay? And that's all that we're doing, is we're taking all the things that we already know, applying that constant of proportionality to write an equation. So part A says write an equation that shows the relationship between the number of people, that's P, that can ride, and the number of wave runners, W. So what I'm going to do is I'm going to go up here to this column. Remember how this is the number of wave runners? We have the W at the bottom, but I'm also going to give this the label of W. And this column here is the number of people. It tells us here the number of people is going to be the variable P. So this means everything in this column represents W, or the wave runners. Everything in this column represents P, or the number of people. So when I have W wave runners, I still go forwards across the table by multiplying it by 3. And when I end up in this column, that tells me how many people can ride, or how many P. That's our equation. That W times 3 is equal to P. Or 3W equals P, or P equals 3W. All of those are the exact same thing. Different ways of representing that same information. So we've written 3 different versions, and for now, I do want you to write all 3 versions so that you really can get in the habit of seeing them multiple ways and recognizing that they all mean the same thing. Okay. Now that we've done the hard part and wrote the equation, which I hope you also see is really not that hard. Now that we've written that equation, we're going to use our equation to determine the number of people that can ride if Peter rents 20 wave runners. So the whole reason for writing an equation is to make our life a little bit easier so that we don't always have to have a table in order to find these patterns and these relationships. So notice what is being said. Peter rents 20 wave runners. What that tells me right here is that this W is no longer W. That W is 20. What do I do with that 20? Well, the equation says that that W is multiplied by 3. So now that 20 is going to be multiplied by 3. And that's going to tell me the number of P, or people, that can ride the wave runners. You all know how to do this calculation. You have calculators if you can't. 20 times 3 is equal to 60. So I just take the information that it gives, I plug it into the equation, or I substitute it into the equation, and then I simplify or solve. P is equal to 60, so in other words, 60 people, making my abstract answer quantitative. 60 people can ride 20 wave runners. That's not too shabby, right? Let's go on to the next one. In this next problem, we see the same sort of setup. We have a situation, we have a table to fill out, we have kind of an expanded table showing how we're going to be going across that table so that we can then, in the end, write the equation that we need. Bubba's Body Shop charges $25 per hour to fix a car. Let's complete the table. If we're spending 0 hours fixing a car, what's the cost going to be? Yeah, that's pretty nice, right? Very helpful. What if I spend 1 hour fixing the car? What's the cost going to be? How did you know that? Yeah, says it right here, $25 per hour. So in 1 hour, that's $25. We're going to pause here. How does that 1 change to a 25? What's happening? And this is why I really love 1s in these tables, because they give us all that information. Going across the table, knowing that we're multiplying, the only way that a 1 can change to a 25 is, Tanner, by multiplying by 25, exactly. We're multiplying by 25. And that's why we can see here 1 is then multiplied by 25 to go forward across the table to get the cost of $25. So the 2, we are going to, look at that, multiply by 25 to go across the table, and we're going to get 50. But now I've gone forwards across the table, multiplying by 25 using that constant of proportionality. What am I going to do right here? Do I still multiply by 25, Luke? Now we're going to divide by 25. Alternatively, we can, if we really wanted to, Gideon? Yes, we could multiply by the reciprocal 1/25. No matter which way you prefer to do this, we are going to get 3. So if we have a budget of $75, he can only work on the car for 3 hours. We can kind of think of it backwards like that too. And now we can fill in the table here. That means going forwards, 3 hours is going to be multiplied by 25. And what is that result going to be? 3 multiplied by 25 is equal to, Luke, 75. Nicely done. And now, again, skipping way ahead. We're skipping all the numbers in between. We're going straight to 8. But that's okay because we know how to go across the table. The 8 is going to be multiplied by 25. And 8 times 25, Trace, is 200. What am I going to do with this t? Let's ignore it for a second. Let's come over here, fill in the rest of the table over here. We have a 4, but that 4 is going to be multiplied by 25 as we go forwards across the table. And 4 times 25, the answer is, 4 times 25 is 100. The 5 is going to be multiplied by 25. And 5 multiplied by 25 is equal to 125. And I don't need to be concerned, even though now I've changed from numbers to a variable, the letter t, it doesn't change the process. I'm going to take that t, I am going to multiply it by 25, and I'm going to get what? What do we get over here? Dylan, what do we get over here? We get 25t, thank you. T multiplied by 25, yes, you can still write t times 25, but we would probably be better off to write it 25t. So part A says write an equation that models the relationship between the cost C that Bubba charges to fix your car based on the number of hours T that he works on it. So now we know what these labels are going to be. This column, you can see the T down here. I'm also going to label it T. Notice how I'm doing the T. I make a little tail on the end, kind of like a type font T, so that it looks like a T and not a plus sign. Okay? And the cost is C. That's the variable that it tells us to use. The cost is C. So when I take T, the number of hours, go forwards by multiplying it by 25, I have 25T. But what does that 25T equal to? It's in the cost column, so that 25T is equal to the cost, or C. We just wrote an equation. 25T equals C. You can write it with the C at the front. C equals 25T. You can keep it T times 25 if you really wanted to. T times 25 equals C. Lots of different ways that you can write that equation. And there is much more of this lesson, but we've had a lot of technical difficulties off the recording, so we are going to end here and we'll continue this on another recording on another day. Thanks for watching. We'll see you next time.